Thanks so much, Stefan, for the introduction. So welcome, everyone. My name is Marco, and I'm gonna have around 30 minutes to give you a very dense, and that in the good sense, hopefully, overview over the requirements engineering process end to end. So I'm trying to put in as many things as might make sense to you. If you feel that this is a bit rushing at the end, don't worry, we're gonna record this and gonna make the data available. A mini disclaimer to start with, right? So this is collective practical wisdom from my own work and also from what we see from dozens of customers, but it's obviously, even if useful, not necessarily the truth. So a lot of the things that I'm gonna be telling about is opinionated and has like a strong practical references. That might not be true for every project. However, probably this is what makes it more useful than just listening to university lecture on the same topic. So you'll still have to think for yourself. But with that in mind, today what we're going to be capturing in the V model of engineering is the left side of this. So basically all the breakdown from initial concept of operations up to detailed design. And we're going to briefly touch upon a bit verification and validation. So that's what we're going to be talking about today mostly. So why should we break down requirements all, right? It's actually to do multiple things. The first thing to do is that we are trying to advance design while reducing mental complexity. That means we're actually trying to get deeper in the understanding of the product that we're developing, while at the same time, though the complexity of the product and its description is rising, we still reduce the mental complexity. So we start having chunks that we can actually work upon. The next one is parallelization of work, right? So you probably have a team and that team needs to be working on separate parts. So what you're trying to do is define interfaces of until which point people have to deliver parts. And the third thing is we're enabling the closure of complex requirements. So a customer requirement might be very complex and very hard to know. How are you actually going to take care of this? And basically enabling, by breaking down requirements, we enable to not only break down the design, but also the verification of it. Let's start off with some small random best practice tips that we have figured out during the way of how to set up good requirements before we come into the a bit more structured way of how it works one by one. So what we learn is that something is either required or it's not needed. So make sure that everything that you do need for your product is actually in, but everything that you don't need is also not in. So it's a very fine line, obviously, to drive. To not have too many requirements, but still have sufficient. I just talked with another person who saw a project of 600 million requirements. That's probably too much. While on the other hand, just having 10 high-level requirements is probably not sufficient if you really want to capture what you're doing. Requirement traces, that means for everyone who hasn't so much experience, the trace between parent and child relationships are as important as its text. So the traces do have most of the information in it about like where the requirement comes from and why you should care about this requirement. So not only the text, but especially these traces are important. Please do never change identifiers. Basically, there's a few people who try to encode a lot of things into the identifier of a requirement, and then they'll find out 1 or 2 years down the project that they have to introduce new requirements, and it gets very, very messy. Then they start changing them, and later someone has written an email which referred to another requirement. In tools like Valispace, we can automatically take care of this, but still, even though tools can do that, I really recommend not to do that. People will have in their minds requirement 324 is about a specific thing. Just introduce a new one with a -b or with a -2 or something like this in between if you want to have it in a specific place, but don't change the identifiers. Another one is everyone needs access. Like requirements are not something that is to be kept secret from different parts of the company. Why? Because the engineers need to understand where their information is coming from. I know that you might, for the very upper level requirements, might want to have a barrier of what is like visible, of which customer asked for what, but at least at a specific level, try to be as open as possible with the access to the requirements. And please try to have one specification per verifiable item. A lot of times we get the questions, where do I draw the line? Do I make one specification with hundreds of sections, or do I make hundreds of specifications? And our best practice that we found is when you have a verifiable item, so for example, a motor that somebody can verify and make a check on, and yes, that motor is fine, that should be one single specification. There's obviously a million things about how requirements shall be well formulated, but I'm going to spare you this part because there's a million websites to just look this up. So I'm just going to dive right into an example. And as an example, we're going to say today, let's model the Valispace 5000. So it's basically vertical takeoff and landing vehicle that should fly autonomously. And let's go through the entire process of how to go from the initial requirements all the way to broken down requirements. So we usually start with some customer specification, and that is usually not very well formulated necessarily. So you can see that it might use different words like must or should instead of shall. It might have many, many properties in a single requirement. So this is usually what you get. You get usually some kind of a messy system. So there's a few things to think about this. The first one is insist on clarifications. That means never accept a list of requirements without really asking and understanding what the customer means with this. So try to really spend sufficient time with the customer to get to know what do they mean when they say must be electrically powered, right? Does that mean that you want to like plug it into an electric outlet, or does it mean that it needs to run electrically and cannot like use that power to, I don't know, do something with hydrogen? So that's kind of questions to clarify. On the other hand, don't try to insist on the form. It's usually not a good idea to try to convince your customer to like reformulate them to be atomic and perfectly written. Rather, try to get an understanding for them and then just leave them as is from a form perspective. Make sure that you store them and version them, and not only the requirements themselves, but also the comments and discussions around them. So usually you should be able to find back the clarification of what electrically means without necessarily having changed the requirement, but at least where the customer told additional information about this, this should be stored and made visible to both you and your customer. Let's come to the second step then. So the second step is basically breaking down the requirements into technical and non-technical requirements. So in this case, for example, we take the requirements that we had from the customer and we now break them down into product specification and operational specification. So that means the product is going to talk about like all the things of how the actual Valispace should look like, and then operational requirements come from how it's going to be operated. So the most important things to like how to do this distinguishment is technical requirements are usually physical. What that means is you can verify them later by only looking at the product, right? So that means I can really just look at the product and see, do 4 passengers fit in here? However, I cannot, just looking at the product, prove that it can fly to 10 kilometers in 15 minutes in a real life example. I can obviously do simulations and so on, but here you can start seeing that you should be able to distinguish between the physical parts that you can verify with the product, and then basically everything else that is about the usage. It might be about the development process. It might be about costs. It might be about manufacturing techniques. It might be about any of these other things. And it's usually a good idea to keep these parts separate so that you have the functional requirements and performance requirements inside the product, and then the other ones in other specifications. So operational is here just an example. There might be far more. Again, why do we do it? It's also good, again, to clarify the requirements meaning. So once you have done that step, it's usually a good idea to go back to your customer and ask them, I've broken them down like this. Is that what you meant? Because usually you had to think quite more about it. For example, here we say shall be exclusively electrically powered, right? And that's a good idea to ask, like, is that what you meant, or is that just an option that you wanted? So go back and then review them with the stakeholders. And here's a few. So in orange, I'm always going to be putting a few pro tips of things that I think is the basics that everyone should have clear. And there's a few pro tips. So one of them is ensure bidirectional linking. So whichever tool or process you use, make sure that it's always easy from this requirement to find where does it come from with the parents, but also at the same time from the other side, what are all the children requirements of that specific requirement? We saw before in like the slides that people said it should be visual. Ideally it's visual, but the most important thing is you should not have to keep that by hand in sync between those two. Like you should always be able to see all the parents and all the children at the same time. And then when you use any numbers in these requirements, if you have a system for this, make sure that these are variables, right? We will show in a webinar tomorrow how Valispace handles this, but even if you don't use Valispace, then try to have those not as numbers defined in a place, but actually as variables somewhere that you can later reference to again, because these 4 passengers will probably pop up in a million more places. If you later have to make changes to your description, that's usually when you have to come back and then change a whole bunch of requirements. And it's really hard to find them all. It's really hard to make sure that you didn't forget one. That's so much easier if you have the variables all in one single place. Then now we've done this, so we basically have product requirements and operational requirements. And now we go into breaking them down into subsystems. So here's an example. The propulsion subsystem shall provide vertical lift of at least 40 kilonewton. So what do we do this for? We do this mainly to allocate responsibilities. What that means is it's 2 kinds of responsibilities. One responsibility is a product responsibility. So it is a propulsion subsystem that is in charge of providing the lift. For propulsion, that might be very simple, but think of another question, for example, when it comes to the question of autonomous flight. It's a very interesting question. Is that a requirement on the onboard computer, or is that a requirement to the ground station that will steer it over the internet, right? So that's what I mean with allocating responsibilities in the product. And at the same time, it will allocate responsibilities on the team. So in your own engineering team, you will now know who you have to go to for these kind of properties. This will be a highly iterative process, right, with your experts and architects from the different areas. So expect this to have several loops of discussions. Should this live in this subsystem or in the other subsystem? Is that formulation fine or not? So this is actually a process that is not done anymore only by the system engineer, but it needs to involve the experts. And then it needs to also be made sure from the system engineering side that it all fits together. Make sure that you don't specify solutions but needs, right? So we're not writing here, there shall be a propeller that does this and that. We write that the subsystem shall provide the lift. That allows a propulsion subsystem to later take decisions by themselves how to meet this need. If you, from the very beginning, have very clear solutions in mind and you require them, at a later stage of your project, you will find problems with that. And then it's not clear anymore for the people working on it. Is it a specific requirement that you wanted to use this specific motor or that you wanted to use a specific technology? Or is that just the first thing that came to mind? So if you ever specify a solution, should be because you really need this. For example, use the motor that our daughter company is producing. That might be a requirement, but in any other case, if you don't have these hard constraints, then always specify needs. Make sure that you capture the actual reasoning, right? So what do I mean with this? It means that you should, again, these kind of discussions, they should not only happen in meetings and on the doorway, they should be somewhere written down of why are you allocating into the system? What kind of trade-offs have you made? So that must be stored in a single place. Your project is going to last probably for a few years until the very end of it. And it's a year from now, there's going to be different people working on the project. They have not been part of the discussion. And even you yourself might not remember anymore. This is the only time where it's very easy to write these things down. Here's a pro tip. We are a big fan of allowing cross-introduced requirements. What does that mean? It means that not every requirement needs to have a parent from an upper level specification. So imagine the customer, for example, didn't ask for a thermal subsystem to exist or to do some cooling, but that might be a result from the motor. So it's fine to have as a parent requirement actually a requirement that comes from a different subsystem on the same level. So for example, you might have a requirement that says you should provide cooling up until a certain level of degrees Celsius because of a requirement that is in a subsystem like the power subsystem, right? And that's perfectly fine to allow these cross-induced requirements. Don't insist of having a parent. It will just make links which are in the end either not existing or not really useful. And again, if you use numbers, make sure that these are also variables. What do I mean with variables? For example, the vertical lift of 40 kilonewton, it is actually something that is calculated from this mass that we had, right? We said somewhere in the requirements that it should be 4 tons, that it should be able to lift. So that lift is dependent on it. So if you don't only store variables, but you actually store properties between those variables, like formulas, you will allow these requirements to actually stay coherent, even if you update one property. And what is exactly a subsystem? That's a very tricky question. Our best practices that we've seen is always to divide it by functionality, not by location. What I mean with this is, imagine you have a thermal subsystem. That's like a functional entity. That's good to have a specification for this. Even if you have thermistors and if you have heating devices in many, many places of your device, right? So we highly recommend don't have like a heating device information on the motor and one on the back of the structure and something like this, but have them all in one single place. So in a logical subsystem, basically. Then how to actually break down requirements when it comes to properties across subsystems, right? So you might have some properties like mass that actually need to be distributed. So while this is something we might do an extra lecture on and how to actually do that, it's more of it's a bit of an art form. So what you basically do is you make a breakdown in your head, either from experience of having seen projects before, or maybe you do like a bottom-up approach where you're trying to figure out what are all the masses of my motors, of my other things, and you start like putting them together. And then again, ideally, what you do is you draw from the experience, and then you define a margin philosophy. So what does that mean? It means that your overall requirement is that you should not exceed 4 tons. You have to make a very conscious decision now. Do you want to put a margin on top of the requirements? So maybe your customer basically asks you for not to exceed 5 tons. And then what you do is you make the requirement just 4 tons. So this way you have a margin when you design. Or do you make it in the breakdown? What means is these 4 tons don't get allocated to each subsystem. Maybe one subsystem get 1 ton, 1, 2 tons, and so on. And then there's still a few left at the end. So that's one way of doing it. Or a third one is within the subsystem. So the subsystems are fully allocated, but then every subsystem is told, although the requirement says you shall not exceed 1 ton, you need to make sure that your design fits within 800 kilograms, right? So this is a decision that you have to make, and there's not necessarily a best practice. You might have some differences in how you want to work, and it might be a combination of those three. What I'm making you aware of is you have to take that decision consciously. Linking numbers through formulas we already talked about. Then let's look at how to deal with software requirements, because that's a very typical case. We actually have software requirements and software. What is this? Is this another subsystem? Is it part of different systems, and so on? Here's our best practice of what we've seen work in the past. We see that if you treat the software specification in a single place, so you just say one specification instead of having the onboard computer and then the I don't know, the motor software and the other software, it's better to have software in a specific place, because usually there's highly interactive parts. Unless your softwares are really completely separate, usually it's the best way to keep them in one place. And then treat the software needs like, again, a customer specification, but for the software team. What does that mean? It means that into the software needs specification, you actually specify all the things that the system team expects the software to do. While then on the software architecture specification, what you do is you basically write the response to that. So you write how the software is going to implement all of these things. So basically, this is an instruction of how to build the software, while this is an instruction to the software team of what you expect to see from it. This is why I'm saying it's a bit like a customer specification, right? And with this, you again have to obviously expect multiple iterations. Also allow for multiple iterations. Don't expect it to be right the first time. The nice thing about software is that you can usually still change it along the life cycle later. Tag dedicated software versions for each need. So that means go back here and say, if you add another software requirement, do we need it from the very beginning, or can the version 0.1 just have these functionalities so that we can already do some system level tests, right? So make sure that you tag software requirements for which point in time these need to be available. Review with everyone. Again, both The needs specification needs to be reviewed by the software team so they understand what is meant with it. But then the system teams and the architects need to look back at the implementation specification to be sure that their needs were understood correctly and that the implementation will actually solve what they meant. Again, obviously write down all the comments and things that you have gathered there in the same place, because you will have a lot of discussions around software and how software should be operating and not. Let's come to external requirements. Usually what you have external standards and regulations, but you might also have internal standards. And there's usually two kinds of standards to distinguish between. Standard number one is standards that apply to the overall product, right? That might be an aviation standard for like our drone. It might be an ISO standard. It might be a lot of things that basically tell you that product needs to, in the end, fulfill certain things. I don't know, in the medical industry, FDA requirements so that you can get your approved part, CE requirements so that you get your stamp for physical products, right? So treat this just like another customer specification. Basically, next to your customer specification, you'll have that kind of specification, and you'll do the same breakdown. So you'll basically link those requirements, all of them, into your product, into the subsystem, first into like the operational and then the product spec, and then into the subsystems and so on. This way you can be sure that on every level, they're basically tackled as needed. The second kind of standard are standards that apply to each part of the product. So what that means is, for example, let's say you have a standard where you say, every time that I produce an equipment, it shall be tested that it doesn't, I don't know, have any electrostatic problems, right? That's a dedicated requirement, not on the overall product. It's not a question of the overall drone that we're building, but it's actually a question for each of the parts. So what we suggest for this is have a single specification for that, and then make an applicability matrix where you say that specific requirement applies to this part, to this part, to this part, to this part, but not to that part. So what that allows you to do is basically to say, I don't know, maybe, for example, the software probably doesn't need to be checked for electrostatic discharges, right? But there might be also other parts on lower levels where you don't want to check it. You might not want to check it on a gear level, but only on the motor level. So these are the kind of decisions that you're going to make. So in this case, basically one spec and then an applicability matrix to which components this is applicable. So for this, make sure that you set up a dynamic tracing for the verification tracking, right? You really want to be able to trace back later, where exactly did we verify that standard? Where exactly did we make this part applicable? This is so important. Otherwise, you're going to come to the end of the project and you're going to find out we didn't do something, and now it's a huge pain to basically go back and decide how to verify all of these parts. Let's talk about failure modes. There's probably a whole lecture that we could do on failure of FMEA analysis and how to get to failure modes and so on. But I want to just focus briefly on how to trace failure modes within the requirements management. So what our best practices is that we've seen is you start with something like a risk register. So you basically list all the risks that could be happening. And then what you do is you basically tag them and tell them, well, this is a critical risk, this is a medium risk. What kind of things are you basically, what happens when this risk materializes, right? Then what you do is you make a failure modes list. So you basically start imagining all the things that could go wrong, right? Engine stops working, loss of control of one engine, all these kind of things. And you have to think about these failures in different places. So basically on the system level, but also on the subsystems, what could go wrong, or even on the component level, one level below. And then you basically go ahead and think, what could be the countermeasures, right? So you're basically saying, well, we must be able to do emergency landings with only 3 engines, right? If we're losing one of the 4, we should still be able to do emergency landing. So what you're basically doing is you're coming up with countermeasures for all the failures that you're not going to be able to accept. So you basically have to see, okay, it's not acceptable for me to basically crash the helicopter. So I will have to have something that makes sure that we can safely land, but a loss of mission, so basically an interruption of my service, is fine. So I do allow that an emergency landing happens. So I don't have to have a mitigation for the emergency landing. I just need a mitigation for the things that I have marked with being critical. And then these kind of countermeasures, obviously, they cannot stay in a dedicated place. They have to flow down now into your product specification, into your ops specification, and so on. Sometimes these can be requirements that you already had, right? It doesn't need to be new requirements, but you have to do the traceability to that requirement to see that all of these are being taken care of. So in short, full traceability is key, from the failures that you're expecting to see, where they could come from, what the impact is, what you're going to do against it, and how you basically take care of this in your tree. And the pro tips here are, you should know from the very get-go what are acceptable risks and which ones aren't acceptable risks, right? Is it fine to interrupt the service, or is it a thing where we need, I don't know, redundancy to make sure that the service always is back up in 10 minutes or something like this, right? Make that sure that you have a clear picture within the entire team of what is acceptable and that you communicate that. Gather the potential failures on all levels. So you should look not only what happens when the drone falls down, but basically look at what happens when the onboard computer crashes. What happens when a rotor blade gets stuck with a bird. Like all of these kind of things. So basically different levels, and they will lead to the same kind of catastrophic failures on the upper level, but still it's important to know where they came from. And then, as I said, countermeasures can be part of the existing design. Very last chapter from my very dense input, and it's how to do verification planning. We're probably going to do other webinars on verification a bit more in detail, but let's just make sure that we figure the most important steps out already. So you should know from the get-go which methods, so which verification methods you're going to use and what you will accept as a closure reference. So when you're writing a requirement, you should already know where, how am I going to be able to verify this, right? So it might be by means of test, review, inspection, but there might be like 10 different kinds of tests, right? So you can think of, okay, are we going to have like a system test and an environmental test, or are we going to just say it doesn't matter, we're just going to do a test? So just know which methods you have. And when I say which kind of what you will accept as a closure, it means, is a test report enough? Is it sufficient to have the results of a simulation, right? So make sure that you know what is sufficient and that you've talked about that with your customer, because your customer or your regulatory body is going to ask you later, how did you do that? And you need to make sure that you're on par with what they were expecting. Make sure that you plan for multiple verifications on multiple equipment for every requirement. This is a very tricky one. This is actually 3 dimensions. So you have a single requirement, and then this can be verified through multiple methods. So for example, through test and review and others, but you might do a test on an engineering model and a test on the flight model and a test on a very early prototype, right? So you suddenly have a matrix where you have a single requirement, multiple verification methods, and then multiple equipments that you are going to test them on. This is something where we see customers struggle a lot. This is a 3rd dimension. And as you know, spreadsheets usually are not 3-dimensional. So you really have to think through how you're going to allow for this kind of complexity in whatever tool that you're using, because you are going to come to that point. In the beginning, you might think, I'm just going to say I'm going to do this by test. But latest, when you have 2 different models, a prototype and a flight model, you're going to ask yourself, where are we going to test this? And this is basically when a lot of work is usually spent and people redo all of their spreadsheets and redo all of the ways of how they think of verification. So if you plan that in the beginning, you really are a few steps ahead. Agree with each customer for the closeout. We talked about this. And then set up end-to-end tracing for everything, for requirements, for your verifications, for the values. So basically, if a requirement says you should be able to fly 200 kilometers, then the verification might be, we verify this through test and through simulation, right? Test on the flight model and the simulation from MATLAB simulation. The values mean, how far did we actually fly in our test, right? Was it 400 kilometers? Was it 301? So these kind of values, store them in a dedicated place. store also the test steps in a place that is also traceable, right? Like you want to be able to prove later that requirement, where was it closed in that specific test step? And then also make sure that you store test runs. So that means you may be executing a test several times, and maybe you're first executing the whole test and then part of it fails and you're just repeating the second part. All of that needs to be traced. So in the end, make sure that you can trace from the early requirements all the way to the runs in a single place, so that when there's any question, either we change the requirement and the question is, what are the tests that we have to change? Or the other way around, where you ask, this test failed. What does that mean for requirements? We didn't fly far enough. What does that mean? Which requirements are impacted? Which requirements do we have to discuss? That's highly important. And then make sure to have some progress tracking with forecasting set up from the beginning. At some point, you're going to wonder, how far are we actually with verifying our requirements? How far are we with the test campaigns? Are we going to meet the deadline or not? This is a really good thing to start from the get-go, to know in a place, how many requirements do you have? How many requirements do you currently have that are not yet verified? How many requirements do you have that are not yet even allocated to a test? How many have been tested, and so on? And to basically trace this over time so that you're sure that you will end up at the end with the right part. And with this, I end my very short, but hopefully with sufficient content that anyone can take something out of it, lecture. I'm really curious to hear your questions.
Amazing. Thank you for the amazing talk, Marco. As Marco already shared in the beginning, it's an extremely dense subject, and we'll probably have to spend quite some more time on exploring some of the different parts of efficient requirements engineering. So 2 questions already appeared throughout the session itself. And for everyone else who is here with us and still hasn't seen the platform on ahaslides.com/rec, you can actually add your questions. So Marco, which question would you like to start with?
Yeah, let's go with the highest voted one. So how you feel about these mutual cross-linked requirements? So subsystem A requires something of B, but B requires something of A. I think that's just life in a real engineering project, to be honest. I really think the main reason what we find is these subsystems are probably connected through physics some way, right? Like, for example, a thermal subsystem really needs to cool down the motor. To do the cooling, they probably need energy, right? That's a normal way of how physics work. There's just no thing that you get for free. So being able to basically do these cross requests from one to the other is, I think, a very normal process, and the power stability is not so good. Is that a problem? And if you know, that comes from this subsystem, you know, I can ask them. They're the ones to be able to make the call. If you don't have that link, then you're not going to be able to answer that question. You might run into problems. The most important thing is make sure that you notify other people about it. So it can be either through reviewing regularly the different specifications, but it might also be a system in which you can, I don't know, add people and notify them, where you can say like, hey, have a look at this, make sure that you confirm this. So you can have like a confirm mechanism where you say, if we have these cross requirements, I expect the other side to confirm that this is fine.
Amazing. Thank you, Marco.
Cool. Let's go with the next one. So can quality checks on requirements be configured in Valispace? So currently this is not something that's part of Valispace yet. So Valispace doesn't like look into the text of requirements and tries to do an analysis. We do know that there's quite a few tools out there which in principle do that.
I think we lost Marco. We'll just wait 1 second to see if he can reconnect. In the meantime, I can maybe take the next question. Mark here has shared and asked, in our experience, is this process attainable in resource constraints hardware startup? So a large part of our customer base has actually started using Valispace already in their startup phase, meaning that we have complete even packages specifically tailored to startups to really be able to help younger companies with setting up the right workflows already from the very start. So it's definitely attainable, and we'll be more than happy to help you on the way.
Hi, I'm back. No good WebEx meeting, no good Zoom meeting happens without an internet drop. So what I was saying is, so on the one hand, I don't think that the most tricky problems are found, but I think if you want to make sure that this is happening, there is a few tools which can do that via API, and Valispace offers an API to the requirements. So you can basically pull in the requirements from a Valispace into a checking tool that basically can go over the requirements and check if they're well formulated, and then give you a ranking back, I don't know, set a tag or something like this, or even notify someone who should update them. So I think you can set something like this up. It's just not natively part of Valispace.
Amazing.
Let's go with the next one. So in your experience, is a full process attainable in a resource-constrained hardware startup? Is that what you just answered, Stefan, or was it a different question?
Yes, I shed some brief light on that question, but you're welcome to elaborate more if you like.
Yeah, absolutely. So, I mean, the question is, what full process, I mean, the reason why it looks like so much is because a lot of thought has to go into the setup of it, right? And I think as a startup, you have basically two options. Either you start to invent that same thing from scratch and have processes manual in there. This will drain you, right? And we see startups that at some point say, no, we just take high-level requirements, I don't care, and throw that away. And then they come back a year later and said, we've been building whatever and it doesn't fit together. So we now, even though we're in the middle of the project, we're starting now a rigorous requirements process. This just drains immense amount of time. So what I would highly recommend is to reuse a system that has been built for exactly what you're doing, right? Like we don't try to invent that from scratch. There have been other people before you who had to do this. And for example, when I was sharing that there's this three-dimensional thing, but between the different models and the way you want to do it, if your tool automatically does that for you, then you don't have to think about it, right? It's like very little work to set a parent-child relationship with a single click. It's a lot of work though to think about, oh, we need this, and do I need to allow for multiple, and how does it work? How do we get it from one spreadsheet into the other? So I do think the most successful hardware startups that we see, they have a good requirement process, but they have also pretty much automated most of the things away, and then they're standing on top of shoulders of good giants, basically similar as like a software startup would use libraries that are pre-made and that they don't have to invent themselves. The best hardware startups do the same with processes and tools on the requirement side.
Amazing. Thank you, Marco. The next question is not a question. Scott had to go, so he's just thanking us. We don't have any specific questions right now, so I just want to share or ask to the audience, we still have a few more minutes left. If you have any burning questions about requirements engineering or about how to do efficient requirements engineering in general, now's a good time. Oh, here we have one. So, any general advice on how to use Valispace efficiently in cases where some sets of requirements are or will be common to several projects?
Yes, I think it's a great question. So there's basically two answers to this. I don't want to go too deep into like the tool part, but I can just say there is a way basically to make specifications applicable to multiple components, and therefore you can have traceability and verification statuses for each of these kind of components, even if they're basically used in multiple projects. The other thing that I can say is there's more to come. We are working on some exciting things. So I think you should keep your eyes open throughout this year, because we might have cracked that already in a way that will make a lot of people very happy. But this is still something we're going to announce probably later this year. So just, yeah, it is possible today, but I think there's even something nice on the horizon.
Amazing. Well, I think we're going to make a whole lot of people happy with this.
Yeah.
We have time for one last question, and then we'll be moving on to the closing part. So if there's anything from your side, Marco, in the meantime, that you may want to share before we close off.
Yeah, I think if there's no questions, just so from my side, we've spent now quite some time like for this talk, and then basically also for an article that we're going to be releasing. We've been spent quite some time like looking back into what people are doing and what we see as best practices. Has been very interesting to see that although people try to build different things, they come up with the same challenges over and over again. And I think the one thing that I can just say here is it looks like a lot, and usually the systems engineers want to focus on actually the design and the building and so on. And here I can just a bit reiterate, right? Like find yourself a partner that you want to work with, or I mean, if you can do the things that I'm saying with spreadsheets, with VBA scripts that you have done in the past, like definitely do this, right? I mean, I'm not. There's a million ways of doing it, and tomorrow we're going to show how this is done with Valispace. But the most important part is don't burden yourself when you're developing complex hardware with the additional problem of setting up the process and tooling. That's just my general thing that we've seen as an advice part here.
Amazing. Thank you very much, Marco. So with this, I'd like to also take the opportunity to invite everyone who's here who hasn't seen it yet. Tomorrow, we actually have a follow-up webinar of today, in which we'll basically be showing how that works directly inside Valispace. So my colleague Kawe, who's also here with us today, who's our customer success manager, he'll be showing essentially what we also show our customers and how we train our customers on the tool to maximally get the value out of it, and how to set up these workflows specifically that Marco has been talking about today. Besides that, as Marco already shared, that we'll be sharing a whole lot of articles coming up on how to do these different parts of the engineering process. There are more webinars coming up. We're trying to start this webinar series, Valispace Live. So this was the very first one, and we're excited to see that there were so many people interested. Besides that, we would be very curious to hear from you if there's any specific topics that you'd be curious about hearing next, since, well, we hear a lot from our customers, but we're always curious to hear from other people that we haven't spoken with in the past. Like, what are the topics that you're most curious about learning? What are maybe some of the challenges that you're facing and that you'd like to hear more about? So if you have any suggestions, you're welcome to put them directly here on AHA Slides, or to hear from you via email afterwards when we share the recording with you and the link to the article. So specifically on change propagation, design trade-offs, a part of that will be covered actually, change propagation will be covered tomorrow partly, and actually design trade-offs, there's already a separate webinar on the link that my colleague Kawe shared here in the chat, where we'll be discussing trade-offs specifically. And the other topics, I think we'll have to take in, think about, and come up with a specific date and time. And you can expect an invitation from our team. Amazing. I think budget tracking is something that will be a very interesting one to talk about as well, especially with a lot of the automated workflows that we've implemented in the past. Great, thank you very much everyone for sharing. Besides that, as I already shared with you before, we'll be more than happy to schedule a call with you, anyone who's interested, just to talk about your requirements process. However that would be, we're always happy to chat. So feel free to reach out to us, solutions@valispace.com, and we can schedule that 30-minute chat. So with that, I'd like to thank everyone who has been here with us today. I'd like to thank Marco as well for his time and his insights. It's been a real pleasure to be hosting this, and I wish everyone a fantastic rest of the day and hope to see you tomorrow. Bye, everyone.